The image of a cyber attack is practically baked into our cultural subconscious. A lone, hooded figure in a dark room, furiously typing lines of code to break through a firewall. But in an era where software can now write and execute its own scripts, this manual, keystroke-driven approach to cybercrime is becoming a relic. We are seeing a shift toward tactical operations that are almost entirely autonomous. Artificial intelligence models are increasingly responsible for the planning and execution of a campaign, rather than just assisting a human operator. A traditional human-led exploit cycle, from identifying a vulnerability to deploying a patch, typically stretches across weeks. An AI system can compress that entire lifecycle down to a fraction of a second. The result is a total change in the nature of the fight. Security teams are no longer monitoring for human keystrokes. They are attempting to defend against attacks that operate at machine scale. To understand this threat, we have to look at the digital architecture. A modern offensive AI functions as an orchestrator. It doesn't attack a website directly. It acts as the brain of a pipeline, directing secondary tools like headless browsers and custom Python scripts to handle the mechanical work. This abstraction makes the threat difficult to isolate. Because the AI is hidden behind layers of automated tools, a defender doesn't see a single malicious model. They see a coordinated swarm of seemingly normal traffic. This multi-agent framework demonstrates how an autonomous attack is organized. It starts with a planner agent, which serves as the system's core logic, breaking the target down and routing specific tasks to specialized sub-agents. The planner assigns the reconnaissance phase to a collector agent. This module can scan millions of endpoints and catalog hundreds of services across an entire network topology in minutes. This parallel scanning identifies hidden logic flaws and weak configurations that have survived years of human review. The findings are then processed by a summarizer agent and logged into a shared memory mechanism. Using that intelligence, the exploiter agent steps in. Before launching an attack, it uses an intra-reflection process to self-correct its payloads, ensuring the logic and syntax are tailored to the specific environment it just mapped. While the system probes for technical flaws, it also runs automated credential stuffing, using AI to analyze password patterns and login behaviors to predict valid credentials. The system continuously optimizes these attempts, timing them to stay just below the threshold that would trigger an automated security lockout. Because this mapping and breaching happens in milliseconds, the intrusion is complete before a human analyst receives the first alert. If the technical perimeter is secure, the AI orchestrator pivots to the most reliable vulnerability in any system, the human element. Generative models can now produce thousands of highly personalized phishing emails at once. By analyzing social media and internal communication logs, they can mimic a company's specific tone and language with near-perfect accuracy. In 2026, deepfake fraud has become a primary tool for bypassing identity checks. AI can now generate the biometric and visual data needed to trick Know Your Customer protocols. Attackers can clone a CEO's voice or fake a video call, using synthetic media to manipulate an executive into authorizing high-value wire transfers. By weaponizing trust, AI effectively turns an organization's own employees into an unintended extension of the attack framework. Once a foothold is established inside the network, the AI deploys its final tool to maintain persistence: polymorphic malware. This is self-modifying code. The AI generates it on the fly, constantly rewriting the malware's structure and signature while keeping its core malicious function intact. The malware changes behavior dynamically based on the host environment, ensuring it seamlessly blends in with legitimate system processes. Because the code's external signature is always changing, traditional antivirus software, which relies on matching known file patterns, is left completely blind. This creates a dangerous asymmetry in the way cyber warfare is now fought. Human defenders are burdened by a standard of perfection. They have to identify and block every single threat to keep the network safe. An AI attacker only needs to succeed once. It can iterate through millions of variations per second without ever experiencing the fatigue that slows down a human team. We have reached the era of the zero-minute threat. This is the reality where the window of time between a vulnerability being discovered and being exploited has effectively vanished. By the time a security analyst sits down to start their shift, the attack is already over, servers are dark, and data is gone. The facts show that you cannot fight machine speed attacks with human speed reflexes. To stop an autonomous AI, the only path forward is to build a deadlier one. We saw the devastating potential of offensive AI, an autonomous hacker mapping networks and executing payloads without human intervention. To stop an attack moving at that velocity, the defense must transform chaotic alerts into a controlled response instantly. For decades, cybersecurity operated on a linear patch cycle. Human teams discovered a breach, analyzed the vulnerability, and wrote a fix. That process usually took days or even weeks. Autonomous agents have collapsed that timeline. Today, offensive AI can discover a zero-day flaw and generate a working exploit in less than 10 minutes. This creates a speed gap. It is a massive time advantage, where an attacker iterates through thousands of evasive tactics faster than a human IT team can process a single alert. The nature of the battlefield has changed. Defenders are no longer countering human keystrokes. They are facing industrialized machine scale. Because human reaction times cannot bridge this 10-minute exploit window, maintaining a secure network now requires the deployment of an autonomous AI defender. Modern security systems meet this challenge through a continuous operational cycle: sense, reason, and act. In the sense phase, the AI ignores traditional software signatures. AI-generated malware is polymorphic, meaning it constantly modifies its own code to evade detection tools that look for fixed patterns. The system builds a behavioral baseline instead. It monitors network traffic and user activity to learn what normal looks like for every entity in the organization. Imagine an AI generates a perfectly localized phishing email and successfully steals a human employee's password. The lock on that account is effectively broken. The defensive AI flags the breach by identifying subtle anomalies. It detects the legitimate credentials being used at 3 a.m. to access a restricted database, with files being moved at superhuman speeds. In an environment controlled by AI, a valid password is insufficient if the user's behavior indicates the presence of a machine. Once an anomaly is detected, the system enters the reasoning phase to plan a counter-strategy. This shows the core reasoning layer. A narrative counterfactual engine generates hypotheses about the attacker's intent. The system validates these against the network's physical reality, checking topology and privilege graphs to determine possible attack paths, filtering noise, and ensuring it only triggers responses for feasible attacks. This multi-layered analysis happens continuously, assessing thousands of data points without manual intervention. Proactive reasoning transforms cybersecurity from a static alarm system into an adaptive digital intellect. The final step is to act. At this stage, the speed of an autonomous system is mandatory. Waiting for a human analyst to review a log would allow the exploit to succeed. The AI performs a risk-scoring calculation, mathematically weighing the severity of the threat against the operational impact of shutting down a server or revoking access. Based on that score, the AI executes a response. It can instantly isolate an infected host, revoke compromised sessions, or deploy a digital decoy to trap the intruder. This data shows the efficiency of the entire loop. From the initial sensing of the anomaly to the final execution of the defense, the process takes 506 milliseconds. This occurs while supporting steps like normalization and structural validation take only a few dozen milliseconds combined. This sub-second response is the absolute only way to neutralize an attack before it spreads across the infrastructure. This automation moves human security professionals from the front lines of triage to the strategic command center. In this human-in-the-loop model, operators set the rules and ethical boundaries. They authorize the AI to act autonomously while maintaining ultimate oversight of high-impact decisions. Modern defensive AI is also moving toward predictive threat intelligence. By analyzing global attack patterns, these models forecast where a hacker will strike before the first packet is sent. Protection now begins at the code level. Defensive agents discover hidden vulnerabilities and shadow AI tools within the software supply chain before the code is even deployed. Today's vast digital world is protected by an invisible war of algorithms clashing at the speed of light. Every secure transaction and protected login is supported by an autonomous digital immune system fighting to maintain the integrity of our infrastructure. As offensive tools continue to industrialize, our ability to interact with the digital world depends on letting these autonomous machines fight the war for us.